Welcome to the pre-calculus video for skill number 18. I can identify domain and range of a function from a graph, including the 15 parent functions. And featured to the right is a compass, and if you notice on the compass there's a red dial with degrees measuring around it. And the trivia question is, what is the purpose of that red dial? Alright, the domain is the set of possible input values. So when you have a function, anything that you're allowed to input is considered part of the domain, and graphically this is often the x variable. Whereas the range is the set of possible output values. Very commonly we have the y value as our output. So graphically we're looking at the y values. We're going to start by looking at the domain and range of the 15 parent functions, and then we will take a look at two other examples. So here's the domain and range of our 9 toolkit functions, as Lippmann refers to them, and on the next page we'll get to the other ones. So the domain is the possible input, so we can put in all the x values that we want into this equation and we still get a result. So our domain is all real numbers. Similarly, all real numbers, here we can put any x in, here we can put any x in, here we can put any x in. Here there are no x values, so it doesn't exist until we hit 0, and then we have x values that produce results. So our domain is x is greater than 0. Greater than or equal to 0. For the cube root, we have all x values, so the domain is all real numbers. For the reciprocal function, we have x values, x values, x values, and then at 0, there is no graph, so we have no x value there. So our domain is x cannot be 0, and then we have more x values as we scan from left to right. Our reciprocal squared, we have the same deal, x values all the way up until we hit 0. At that point we do not have x values that are part of the graph, and then we continue on rightward. If we're looking at range, we're looking at the possible y values. So there is no y until we hit the c, or the constant, the number that is our equation. For the identity function, we actually have y values all the way up, so our y values is all real numbers. For our absolute value function, there is no y values down here, but starting at 0, we start getting y values. So this is a case where y is greater than 0 is our range. This also happens with a quadratic equation, no y's until we get to the axis, and then we have y values. So the quadratic function has y greater than 0 is the range. The cubic, all y's. The square root is y is greater than or equal to 0. And cube root, all real numbers. For the reciprocal, we don't have a y at 0, so we have values all the way up till 0, and then from everything beyond 0. So our range is y does not equal 0. And the reciprocal squared, we have no y values until 0. We don't include 0, but everything exists above 0. So there's our range. When we look at the remaining 6 functions, the remaining 6 parent functions, you can see that the domain is all the x's exist, so all real numbers, but our range is limited to only positive values, so y is greater than 0. Our range for the sine function, it's actually trapped between positive 1 and negative 1. And then the range for the greatest integer, we only have values that are integers. So our range is the set of integers, and that fancy z means integers. Whereas our domain, we have all the x values, so all those x values are eventually covered in the graph. So we do all real numbers. Similarly, with our cosine function, we're limited between -1 and 1 for our range. Our logarithmic function, we have no negative x values, so only positive x values work. And our logistic function, all x values work. And our range, we're limited to from 0 to 1, and it stays between those lines. So our range is 0 is less than y is less than 1. Moving down the page, we've got our first example. It says identify the domain and range of the graph, and this is a little bit more like what will exist on the skill test. You'll see a graph, and if we are sweeping from left to right, we have x values, we have x values, we have x values. There's a jump, but it does exist there, and then it continues to exist to the right of that spot. So because there's arrowheads at both ends, we know it's going to keep going forever outward and forever outward, so our domain is all real numbers. Our range, on the other hand, what we have is if we sweep from the bottom, we have y values, we keep having y values, we keep having y values, we keep having y values, all the way up until a y value of 2. So our range is going to be y is less than or equal to 2. Okay, so for the final example, we have a rather complex graph that we need to identify the domain and range of, and the same process works. When we're starting with the domain, we're going to start sweeping from left to right, and at -3 we start getting values, and we keep having values all the way up until 1, where we run into a vertical asymptote. So this blue portion, solid circle to open circle, solid circle to open circle. That's this piece of our domain. Then we have this kind of curve that's trapped between the two vertical asymptotes. That would be from 1 to 3. And then we have this last little segment, which is open circle to open circle. That's 3 to 4. If we're going to do our range, we start at the bottom and we have stuff that exists, and it keeps existing as we sweep up until we hit 0. And at 0, the curve stops and we have a leap from 0 up to 1. So the curve actually touches 0, so we want to put a hard bracket on that curve. And then we leap up, and the second piece exists from 1 all the way up to a height of 2. And similarly, we notice that there's a closed circle at that height, so we're going to have a hard bracket on 2. We want a soft parentheses on 1 because of our open circle there. Alright, thank you for watching the video, and the answer to the trivia question is the red dial is for assisting with calculating the declination. At various places on Earth, the magnetic north is slightly askew from true north, and so we use a declination setting to accommodate the difference between what our compass says is north and what true north actually is.